What's up? Gonna look at this IB test here, reviewing the first two topics. Let this function from -3 to 4, write down the value of f of 2. All right, 3 points. We love this. F of 2, remember 2 is the x value, so that would be this location right here. So for part A, f of 2 is equal to 1. 1 mark for sure. Let g of x equal to, let g of x equal to f of x minus 1. Okay, sure. Sketch the graph, determine the values. Okay, so g of x is gonna, so this f of x is really the y. So what we need to do is take all of our y values and translate them by multiplying them by 2 and subtracting 1. Okay, so g, I'll do in a different color. Let's do orange. G of x can be in this color. Multiply by 2, subtract 1. So 3, 6, 5, 2, 4, 3, 1, 2, 1, 0, 0, 1, negative 1, negative 1, negative 2, negative 3. I don't really have a good spot there. Let's pick this one. 1, 2, 1. And it is a nice curve. This is a nice line. Okay, this is pretty easy. It's gonna stay as a nice line for this half, and it's gonna stay a curve for this half. Something like that. Okay, that's not too bad. 2 marks for free. We're doing great. Determine the value of f of g. So that means that I need to take B is graphed. C, g of f of 2 is the same thing as g of f of 2. And that means I want f of 2, which I already figured out is 1. So that means I want g of 1. And g of 1 is 3. Nice. Another point. And D. Solve the equation f of g is something is equal to 0 and x is greater than 0. Okay. So we need to put g into f and have it equal to 0 when x is greater than 0. Okay, so let's make sure we write this down. F of g of x is equal to 0. That means that we're talking about f of g of x. When it says this, that means x is a variable, and that means that y is equal to 0. So we need to figure out the place. We need to figure out the place where f of x is 0. That's the black graph. The black graph is 0 right here. Okay, so this is f of 3 is equal to 0. So now we want to figure out, how do we get g of x to be 3? G of x is the orange graph, and that's this piece. Or hold up. G of 1 is equal to 3. So that means that f of g of 1 is equal to 0. Because g of 1 becomes 3, because f of 3 becomes 0. And so the question, just to make sure we answer it, f of g of what? This number needs to be 1. Okay, honestly, that wasn't too bad. We'll be taking our 1, 2, 3, 4, 5 marks. Sweet. No calculator, 5 marks here. Okay, we did one like this before, actually. We just need to use our law of sines, law of cosines, maybe some Pythagorean theorem type stuff. Let sine equal to 2 over 3. So remember, this is opposite and hypotenuse. And so 2 and 3, we can use Pythagorean theorem. A squared plus 2 squared is equal to 3 squared. That's going to be a squared plus 4 is equal to 9. It's going to be a squared is equal to 5. It's going to be a is equal to square root 5. I'm probably going to get a mark for that. And what is the cosine of this? The cosine would be adjacent over hypotenuse. And so a would be square root 5 over 3. Let me label this better. The cosine of x would be square root 5 over 3. And I need to be a little bit careful here. This is in quadrant 2, and that would be sine positive, cosine negative. So for this question, cosine is negative. If I had to guess, I'm probably, for my 3 marks, I'm probably getting 1 mark for doing the Pythagorean theorem, 1 mark for getting square root 5, and maybe 1 mark for the negative / putting it all together. Sweet. That's, all of this is part A. Part B says find cosine of 2 theta. This is double angles. I'm going to need my formula booklet. I lent it out. So we have double angles, and we have a bunch of double angles, and we want to make sure that we choose the one that we need here. So you see we have several different options. Double angle that uses both, double angle that uses only cosine, and double angle that uses sine. So for this question, it asks us to find cosine of 2 theta, and it seems like we have a couple different options here. We could use the one that uses them both, or the one that uses only cosine, or the one that uses only sine. I suppose we could use any of them. I guess I would try to use the one that uses only sine, since sine is given to us in the question. And so probably going to try to use the one that uses only sine. So I'll say that cosine 2 theta is equal to 1 minus 2 sine squared theta. That's probably 1 mark by itself. 1 minus 2, and it told us 2/3 squared. This is no calculator, so let's work on this. Cosine 2 theta is equal to 1 minus 2. That would be 4 over 9. Cosine 2 theta is equal to 1 minus, that would be 8 over 9. And 1 minus 8 over 9, cosine 2 theta is going to be 1 over 9. Nice. Not too bad. Again, feeling pretty good about my marks. We have a yes calculator question. Let f of x be this. It doesn't scare me too much because it's it's not really that bad. It's in kind of like vertex form, if you want to think about it that way. Yeah, it really doesn't seem too bad. For x is greater than -2, because we have the vertical asymptote, makes sense. The diagram below shows part of it, okay, it makes sense. Find the coordinates of the x-intercept and the y-intercept. This is just going to be a calculator question, right? I mean, I just need to use the calculator and figure this out. So the x-intercept. Alpha y equals enter the natural log of x plus 2 over 2. Let's go ahead and set my window so that it looks pretty similar. Okay, sorry, just my window. Put my x minimum at -3. Let's just go to 10's fine. Y minimum, how about -5 to 5? See how that looks. Okay, so not too bad. I'm gonna need to find my x-intercepts and my y-intercepts. So calculate my 0. Nope, that's not gonna work. Second, calculate my 0. Scroll all the way over here. It looks like it's a perfect integer. Yep. My x-intercept looks like it's -1, 0. And my y-intercept. Second, calculate. Now, my y-intercept is going to be where x is equal to 0. I can just go to the table for that. When my x is equal to 0, my y is equal to 0.347. Cool. I think that's 2 marks, and there's no possible way I got those wrong. Find the equation of the vertical asymptote. Vertical asymptote requires me to, I guess I can't show you this. Vertical asymptote requires that I understand how these natural log graphs work. One of the easiest ways to think about how they work is likely that for an exponential graph, you have this horizontal asymptote at 0, and it goes to the point 0, 1. And your inverse of that is the log graph. And the log graph has this vertical asymptote, and it goes through 1, 0. So our log graph normally has a vertical asymptote at 0. And then, if I consider my equation, the natural log of x plus 2 over 2, I could also think about that as like 1/2 the natural log of x plus 2. And so this is going to be a vertical stretch. Really, it's going to be more like a vertical compression. And this is going to be a left 2 translation. So I just need to take everything and move it left 2. That's going to move my vertical asymptote to x equals -2. That's it's not too bad. Pretty easy. Part C. Find the area of the region enclosed by the graph of f, the x-axis, and the y-axis. Let's make sure we know what we're talking about here. Here's our graph. We need the graph, the x-axis, and the y-axis. So it's got to be this. It's got to be this little spot here. Calculate the area. Now, this is an interesting little question. If I go to calculate the 0, the value, the minimum, the intersect, the derivative, or the integral, we actually do want one of these. We want the integral. We didn't end up doing this for very long. It's really an AI topic more than an AA topic, which is that an integral is the area under the curve. And so if we want to solve this, we can just do the area under the curve. And it's actually a really easy question to kind of set up. I'm noticing it's only 2 marks, and so I'm likely getting, just 1 mark for setting it up and 1 mark for the calculator answer. I have my 1/2 natural log of x plus 2. And so if I wanted to set up an integral, set it up like this. Now I don't want to do the indefinite integral, I want to do the definite integral, and I want it to be, for this little spot here, which is from -1 to 0. And so I'm going to put a -1 and a 0 here. Could I calculate this by hand? I could do the integral of this. In fact, I don't know that it would be, a crazy integral. But when I think about the integral of natural log, I know it's 1 over x, but then I think 1 over x is the derivative of natural log, not the integral. And the integral of natural log is actually something that we don't really like at all. So before I try to do this integral, it's a calculator question. Second, calculate the integral. Now you can see if I do it this way, it's literally just going to put me on the graph. And I could just say from -1 to 0. And it will even color it in. Here, let me zoom in a little bit more. Let's do from -2 to 1 and from -1 to 3. So here's my graph. And I can say the integral from -1 to 0. And it will color it for me and then tell me the answer. It's telling me 0.193. And yeah, not too bad. I could also out here do a calculate the integral from -1 to 0. I just need to type, this whole graph in again. I could maybe even just, you want to be really fancy? Sheesh. I could type in the natural log of x plus 2, x plus 2 over 2. Getting the same answer every way, of course. And so, there's our answer. Did I calculate the intercepts, the vertical asymptote, and the area? Easy. Let's move on. Number 4. Finally looks like maybe we're getting a question that's a little tough here, maybe. Let this function, following diagram shows part of the graph. P and Q look like intercepts. The graph has intercepts at P and Q. And the y-intercept at -10. Makes sense. Write down the value of P and Q and the value of A. Okay. Does it say anything about P or Q, one of them being bigger than the other one? No. Okay. This shouldn't be too hard. My intercepts are wherever f of x equals 0. So maybe I could set it up like f of x equals a, x plus 1, x plus 5 equals 0. Then I could solve this, x plus 1 equals 0, x plus 5 equals 0. But of course, P is equal to, remember P and Q are the intercepts, not the factors. So if the factor is 1, then the intercept would be -1. So P is equal to -1 and Q is equal to -5. I wrote these as straight up values and not put them in their parentheses because it just says the value of P. It doesn't say what is like the intercept. So I'm pretty happy with that. That's part 1. Part 2, find the value of A. So A is up here, A is the number in front. I don't have that much information to go off of. P and Q doesn't help me find A. I've already got this information. The only thing I have is these and the y-intercept. This y-intercept is 0, -10. So that's really the only information that I have. And of course, I'm going to have to combine these two pieces of information in order to get the next answer. So I'm going to take this and put it up here. So the way that looks is that I have f of x is equal to ax plus 1, x plus 5. That's the rewrite. Now I'm going to use 0, negative 10. So f of 0 is equal to a 0 plus 1, 0 plus 5, and that is going to be equal to negative 10. That's going to be f of 0 is equal to a 1, 5 to negative 10. And so pretty obviously, thinking and writing at the same time, a is equal to negative 2. That way negative 2 times 1 times 5 is going to be negative 10. Everybody's going to win. Nice. So now I've kind of figured out, it seems to be the entire equation. Find the equation of the axis of symmetry. Okay? A couple different ways for me to find the axis of symmetry. I could try to find the axis of symmetry by just saying it's got to be in the middle of these 2 points. I could say what is P, what is Q, and I need the number in the middle of P and Q, and then I win. That's the axis of symmetry. I could also find the axis of symmetry by foiling this out. Give me a sec. Mr. Calder. We're going to have physicals tomorrow. Yeah. So sorry. Bye. Soccer. I could FOIL this out and use my axis of symmetry formula. I'm probably going to do it, it's only 2 marks. I'm probably going to do it the easy and the short way here. And I'm going to say that the axis of symmetry is between coordinates with the same y values. Wow, I don't know what that word is. Y values. Now that sounds complicated, but basically if I've got 2 values and they have the same y value like this, then the axis of symmetry is in the middle. So I'm going to use my 2 coordinates here. That would be negative 1, 0 and negative 5, 0. These have the 2 values, and I need to figure out what is in the middle of those 2. And so I could do negative 1 plus negative 5 divided by 2. Find their average by adding them up and dividing by 2. That's going to be negative 3. So the axis of symmetry is equal to, maybe I'll put an arrow because the axis of symmetry has its own equal sign. X equals negative 3. I'm probably going to get points deducted if I don't have this equal sign. It has to be an axis. It has to be a line. And if I just put negative 3 without the equal sign, then it's not a line. Okay. Part C. Find the coordinates of the vertex. Okay. If I'm finding the coordinates of the vertex, I have a couple different ways I could go. I could try to do completing the square. If I did completing the square, that would put the whole thing into vertex form, and then I could get the h and I could get the k, and that would tell me my vertex. But again, going about the easiest way possible, the vertex is the coordinate that is on the axis of symmetry. This is the vertex right here. And since I know that the axis of symmetry is at negative 3, and that's the x value, then all I need to do is find the y value. I know, for example, that my vertex is negative 3 something. I just don't know what it is. So in order to figure it out, I could do f of negative 3 is equal to, take my equation here, and I'll put the negative 2 there. So negative 2 times negative 3 plus 1, negative 3 plus 5. And I just need to simplify this out. That's a negative 2, that's a negative 2, and that is a positive 2. 2 negatives makes a positive. 2 times 2 times 2, that makes 8. And so, there you go. I think that's good enough. I think that I found the vertex. I think I pointed out, the vertex is on the axis of symmetry. So I just had to use this -3 number again. The graph of a function g is obtained from the graph of f by reflection in the y-axis, okay, followed by a translation of 2 units in the direction of the positive y-axis. Okay. The point -2, 6 is mapped to Q, and I just need to find Q. Okay. Well, I need to make sure that I do a reflection in the y-axis. And so let's make sure, because the terminology is a little funky there. I want to make sure that, am I supposed to be reflecting it over the x-axis or over the y-axis? Yeah. So in order to flip it in the y-axis, it's the same thing as flipping it over the y-axis. And so I'm going to be looking at taking this and flipping it over like this a little bit. But then don't forget, I also need to shift it up 2. And so let's take a color like maybe pink. And so I should have a graph that looks something like this. It's not the best, most perfectly accurate shape ever, but we'll just call it that. So we have this point, -2, 6. And where does it end up? So when I flip something over the y-axis, like let's say, I flip this point and it ends up over here. How does that change? Okay, as it flips across here, the x-axis is going to become the opposite of it was before, right? If this is 0, -10, it's not going to move because the x-axis doesn't have anywhere to go. However, if I flip P is going to come all the way over here to its opposite counterpart, the kind of positive version of P. And so I need to make sure whatever I do with my X, I flip it to the positive version. Now the other thing I need to do is make sure that I go up 2. And what happens when I go up 2? That means I need to take my Y value and just increase it by 2. So D, it shouldn't be too hard of a question here. We should have reflect in the y-axis. What does that do? That means that my x needs to become negative. So x maps onto -x. Then I have my translation, positive y-axis. And what does that mean? That means my y will map onto y plus 2. And so that means that my original point P of -2, 6 can map onto Q. And where will Q be? Take the x and make sure it becomes negative, so it's going to be positive 2. Take the y and make sure to add 2, so make sure that it's 8. Now this was 4 marks, which is why I felt like, whoa, I kind of need to make sure that I do the most here. Let's read the question again. Is obtained by reflection and translation. The point on the graph is mapped to point Q. Find the coordinates. So it didn't ask me to graph the Q. All it asked me to do is find Q, and I found it here. 4 points does seem like a lot. 4 marks does seem like a lot. Probably get 1 answer for the 2, 1 answer for the 8, and maybe I get 1 mark each for explaining each thing. got one more question here. Ooh, I like these kind of questions. The following diagram shows triangle ABC. Okay, point D lines on AC so that DB bisects CBA. Okay, so that means that these two thetas are equal to each other. So that means that, DBA and DBC, that those two angles are equal because they've been bisected. Okay. The area of triangle ABC is 3. Okay. Total area equals 3. AB is 2 square root 7. BC is x. CBD is theta. And sine of theta is 3/4. Okay. Find the value of x in the form of AB, where A and B are positive integers. Okay, so I'm not allowed a calculator here, so I'm gonna have to do some stuff for sure. What can I get figured out here? I know. I do know the area, so I kind of want to include the area somehow. And I know that I also have shared sides here, where DB is the same side for both triangles. Normally, when you have two touching shapes, you're gonna have to work in the wrong shape before you're allowed to bring stuff over to the correct shape. I do know a trick that when triangles are set up like this, that they're not gonna end up being similar, but it's gonna work out where they're gonna be proportional. So how am I gonna set this up? I know I need to use this, and I know I need to use this. So I'm gonna need to use these different strategies here. The area of the whole thing. Well, the area of the whole thing is the area of both of them added together. If I want to use sine of theta is equal to 3/4. I'm worried about that sine of theta is equal to 3/4 because we don't have right triangles. So here's what I'm thinking. I know I need to use sine, and I know I need to use area. And so I know in my formula booklet here, I have this formula. Area of a triangle and sine. So let's get that down. The area is equal to 1/2 AB sine C. So hopefully, okay, it's coming together a little bit. Hopefully I can figure out that the area of the whole triangle is equal to area of the big plus area of the small. I can say that the area of the whole is 3, that the area of the big is 1/2 2 square root 7 AB sine C. And now this is what I don't know. I don't know this. DB. Now sine of theta, and I'll replace that next time. And I'll add that with 1/2. Again, I don't know DB. And I don't know X sine of theta. They're both sines of thetas. 3 is equal to 1/2 2 square root 7 dB sine of theta. They already said sine of theta was 3 over 4. 3 over 4 plus 1/2 dBx and sine of, no, oh, frick. Well, hideous paper now. Oh, you guys didn't even see me make the mistake. So this is the area of the whole and the area of the big and the area of the small. I replaced my sine of theta with 3/4 because that comes from the question that the sine of theta is 3/4 right here. Now I've got my dBs in both of these and the x. So I think that when I move all this stuff to the other side, that am I gonna have a dB on the top and a dB on the bottom and they'll just cancel out? No, because I'm gonna have this minus. Okay, well, let's just see if we can make some progress here. I know that I can do some canceling out. This 2 and this 2 will simplify a bit. Maybe that's not really going to work together. Maybe this 2 could work with that 4 and make an 8. So maybe I could rewrite this again as square root 7 times dB times 3/4 plus 1/2. Don't write that. 3 over 8. That's the 3 and the 8. dB and then the x. I could subtract this to the other side. 3 minus square root 7 dB times 3 over 4. And then that would be 3 over 8 dB times x. Again, I could just do more algebra and just divide this stuff the other side, I guess. So what about 3 minus, everything's got a 3, I'm noticing. So those 3's are all going to simplify, but let's make this 3 square root 7 over 4 times dB. And I divided by this. Three over 8 dB. Now I cannot simplify these dBs because I need all 3 parts. So I'm going to have to figure out the length of dB. But I do see maybe a little bit more simplifying I can do. They have a 3 and a 3 and a 3 all in the numerator. So all those 3's can go away. So I'm going to have to come back to this. But it looks like okay, I gotta figure out what dB is. dB within my triangles, and they're not right triangles. What have I used from the question? I used the area. I used this as my sine. I don't really have that much. I just know that those 2 sides are the same. It's a big side. When triangles are set up like this, then their sides are going to be proportional as well. But we don't have any information about the proportional sides here, so I'm not worried about that. I can't use, if I try the law of sines, I need to have opposite pieces that match, right? So theta, and then this would be theta over here. 2 square root 7, and then this would be the angle that works. But I don't have any matches. These don't match. if I wanted to use the law of cosines, I would have to know 3 sides. Or maybe I could do 2 sides. I don't know 2 sides. I only know the 1 side. Set up a dB. That doesn't make any sense. The area of the triangle. Can't use that. Arc, no. Tangent, no. Pythagorean. Okay, I haven't done anything with like the Pythagorean identity, which could help me find cosine. But then again, I don't have 2 sides of either piece. Got probability stuff. There's nothing to maximize. There's no calculus involved. All right, we're stalled out. Look in, Mr. Carter. Distance, the area. So I would need to find x in the form of a fraction where a and b are positive integers. Now, if they're positive integers, that means an integer doesn't have a decimal, right? And so that means that the square root of 7 is not in a good spot either, because the square root of 7 is irrational. Now, if dB is also the square root of 7, I think that's going to work. Stall out just a bit. Let's see if we can do just a little bit more math. See if it comes to us. I'll put the x on the left because I like the x on the left better, and maybe I'll try to get rid of this 1/8. So I'll multiply top and bottom by 8. So that's going to be 8 minus 2 square root 7 dB. Again, I can't cross those dBs out because this 8 does not have a dB. I could divide everything by dB, but then I would just have an 8 over dB, and that's not very good either. I do have this 2 square root 7, which showed back up again, which was in the question, but I don't see how that helps me at all. Dang, this test was going so easily. Bummed that I'm a little stuck. Following diagram. Now let's think about it. Let's think about our marks here. It's only 6 marks. We've done the area, we've done the big and small. We know that area, and we're adding them up. Okay, cool. We use the 3 over 4 in both of these positions. We can't use the area formula of just the small because we don't know the area of just the small or just the big. We don't know either one. All right, it seems like we need to use the Pythagorean identity. I'm not really sure how this is going to help, to be honest. But we'll just get into it and make it work. Cosine squared plus sine squared is equal to 0, or is equal to 1. Whew, is equal to 1. And then that's going to be cosine squared x plus, now sine is 3 over 4. 3 over 4 squared is equal to 1. It's cosine squared x is equal to, that's 9 over 16. 1 minus 9 over 16. That's cosine squared x is equal to 7 over 16. That means that cosine of x is equal to square root 7 over 4. I have a feeling that I'm getting a mark from that. And I have a feeling that that square root of 7 is meant to work with our other square root of 7, so that they will cross out. But as far as things that have cosine in them, I have this cosine rule. I only have one of the sides, man. Go for a walk, wake it up, see what happens. ABC is the whole triangle. Oh, dang. Oh, that's finally come to me. Okay, we've got it. The area of the whole triangle, right? We know that the area of the whole triangle is 3. And we know that this is 2 square root 7. We know that this is x. We can do the area of the whole triangle, and we can count this b, which is 2 theta. And so what we can do, this is a good call here. The area of the whole thing, are we on screen here? The area of the whole thing is 1/2 AB sine C. The area, of the whole thing is 1/2 A, 2 square root 7, B, x, and c, sine c, which is 2 theta. Sine of 2 theta. Now, sine of 2 theta, well, we're going to have to use our double angle identity. The double angle for sine is the easy one, 2 sine cosine. The area of the whole is equal to the 1/2 and the 2 are going to cross out, square root 7 times x, 2 sine theta cosine theta. Now we're going to have to bring the cosine and bring the sine from the given. So the area of the whole triangle is going to be 2 square root 7 times x times sine 3 over 4 times cosine, which we found, square root 7 over 4. The area of the whole triangle is 3. That's going to be, figure this stuff out now. On the top, a 2 square root 7 times x times 3 times square root 7. And on the bottom, 4, 16. Simplify this. We're right at the end. 2 over 16 is an 8 on the bottom. Square root 7 makes a regular 7 times 3 is 21. Multiply times 8. 24 is equal to 21x divided by 21. X is equal to 24 over 21. X is equal to 8 over 7. Oh no, it's behind. Right when we got to the end, it's behind the camera. Wow. Dang, this was crazy. I honestly thought I was about to get stuck and, be a little frustrated. I even actually went for a walk and it actually worked. Recognizing this as 2 theta. Man, in a lot of ways, I'm kind of bummed that I didn't see that sooner. But honestly, it worked out, I guess. Again, all of this stuff with the DB, it was a good try. It was good ideas. But again, I just don't think there was a way for me to crack into that DB. However long DB is, I don't know. Honestly, maybe now we could start to figure it out and work backwards, and maybe our little stuff we did here would make sense. But from what I'm seeing, nice. This worked out pretty well. The whole area is 1/2 AB sine C. We don't know B, but it's 2 theta. And 2 theta, we can use the double angle. We can use the sine and the cosine. We can simplify everything and get 8 over 7. Wow, pretty cool question. 5 out of 10. Yeah, it wasn't. This is like such a cringe math teacher thing to say. It really wasn't that hard mathematically. But as far as getting on the right path, I was off on the wrong path. It turned out that all of this was completely wrong. And then this was the path I needed to go down. Wow, cool question. Glad I worked through it. How long is this little recording here? What does it say? Oh, well, not too bad. Hope this helped.